Okay. So I'm going to come up with a scenario here for us. I'm going to use a different pen because I feel like I'm going to bleed through otherwise, so I'll just use a regular kind of pen here. Okay, question. When Tyler C. comes back, yes. Okay, so first of all, let's refresh our memories, right? If you forgot from that quiz, or if you got to the quiz and you're like, oh crap, I forgot what the slope formula is. Okay, remember that the slope is what minus what on top? y2 minus y1 on top over x2 minus x1. Or you can think of the change in y over the change in x. Okay, that's another way to think about it. Okay, so y2 minus y1 over x2 minus x1, or the change in y over the change in x. Okay, that's the slope. Or if you want to say the average rate of change too, that's another way to say the same thing. Okay, so let's do a little graph here. All right, and let's see here. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so give yourself a line right there. It's about 8 blocks long. Okay, 1, 2, 3, 4, 5, 6, 7, 8. 8 blocks long, and 1, 2, 3, 4, 5, and 6 blocks wide there. Well, let's go ahead and make it 7 so you can put the arrow at the end there. Okay, so 7 blocks wide. So 8 high, 7 long. Okay, 8 high, 7 long. Okay, so 8 high, 7 long there. Okay, put arrows at the end just so it keeps going, right? Stuff like that. And then we'll put some we'll put tick marks at each block here on the y-axis, and we'll go from 20 all the way up to 140. We're gonna start at 20 and count by 20s. Okay, and then every block on the x-axis we're gonna count by 10s. Like that. Let's label the x-axis as age in years. Okay. Age in years. And the y-axis, let's label that as heart rate. Okay, and it's in beats per minute. Okay, your heart rate in beats per minute. Okay. All right. And then once you've got that, I want you to go ahead and then graph 2 points. There's going to be a point at 10, 120. Okay, and there's going to be a point at 40, 60. And then draw the line that goes through those 2 points. Draw the line that goes through those 2 points. So 10, 120, 40, 60. I've got it graphed up here too. So once you have that line graphed, then just give me a second here. We'll talk about things. So up to this point, when we talk about slope, slope doesn't have much meaning. Okay, up to this point, when we talked about slope, slope didn't really have like a meaning to us necessarily. I was trying to kind of get it across to you when we do things like finding my speed and stuff like that, okay? But like when we had a problem like this on our little, like checkup there, okay? And you found the slope, you just got this number -3 over 1, okay? Or -3 every 1, okay? But the meaning behind this here is that every 3 that you move down, right? So -3 is like a downward movement. So every 3 that you move down, this +1 tells us to move what direction? Right, how many?
1.
So yeah, every time you move down 3, you need to move right 1. Every down 3, right 1, okay? Some people maybe got a +3 over a -1, okay, which is the same thing, right? If you got +3 over a -1, this tells you you should always move how? Up 3 every left 1. So again, we can say up 1, 2, 3, left 1. Up 1, 2, 3, left 1. You can see we're still on the line, right? But that doesn't have too much meaning. But then here, we put in some labels on our x and y axis, and now we have a little bit more meaning, okay? So we have age in years and the heart rate in beats per minute, okay? So you can kind of see here that as you get older, what happens to your heart rate? And what? Decreases. Yeah, it's slowing down. I don't know. I think this is like a resting heart rate maybe or something like that. And obviously, I doubt that we could say that this is a perfect relationship, a perfect line relationship here, because what happens when you're 70 years old? Your heart stops beating, right? But that's not true, because I'm sure some of you have grandparents, maybe even great-grandparents that are older than that, So obviously, there's something a little bit off with this data. But that being said, we can still kind of interpret what the slope means in this context. So we have age. So now our x variables, right, they're not just x numbers. They're not just some random number. They have a meaning. They're age. That's ages, okay, in years. And the y coordinates as well. They're not just without meaning. That's the heart rate in beats per minute, okay? And so then we're going to now find the slope. Okay, so let's do that first. And again, you find the slope just like we have in the past, using 2 points. And then, you're doing the y2 minus y1 over x2 minus x1. So let's see here. Let's go to Kendall. So Kendall, can you set up the slope for us here? What will be our calculation? The slope is going to equal... What's going to be in the numerator of the slope? What minus what? Okay, great. 60 minus 120. So she's saying that's her y2 and that's her y1. And then in the bottom, 40 minus 10. Okay, and again, so there's the x2, there's the x1 right there. Okay? And now we just simplify. 60 minus 120, what does that equal? Negative 60? 40 minus 10? 30. Okay? At this point, we found the slope. And we could stop here and say what the slope means. Okay? What would be the label? What would be the label for the numerator? What units would that numerator be in? Negative 60 what? Beats per minute. Why did you use the y-axis label here, Hannah, as the units? Yeah, the y's are we subtracted here, right? This was a y2 minus a y1. So these are y coordinates, so this negative 60 should have a y label. It's beats per minute. Okay? Oops, I'm off the screen. There we go. Okay? And then what would be the x-axis? What would be the x label here? For the 30. It would be years, right? So what's a sentence that we could use to describe this meaning right here? We could say something like, I'm going to say it for this one, Matt, and then we'll give you guys a chance. Let's see. We could say your heart rate I want to be careful what I say here, because if we say decreases by negative 60 beats per minute, that's going to be like a negative, an opposite. Like that'll be too many. So I'm going to say your heart rate changes negative 60 beats per minute. Okay, every how many years? 30. Every 30 years. think so. I think that's how that works. Kind of like a Dementor or something like that. Yes. Oh, that's pretty cool. Actually, funny story. There's this like group of people, I want to say like back in the 60s or something like that, called sun starers, and they believed that they could get their sustenance by looking directly at the sun with their eyes, and they would receive nutrients that way. Well,
Did they lose vision?
I don't know, but I don't know that they claimed they didn't have to eat. They would just look at the sun. And well, and the thing is, like, you know, is someone following them around 24 hours to check to make sure that they're not actually eating something too? Who knows, you know, kind of thing. But anyway, it was a very interesting scenario. Now, and now you have superpowers. Great. The superpower of losing all your hair and radioactive poisoning, probably, right? And yeah. So, all right. But seriously, though, yeah, it's interesting. But I don't know. Anyway, you can. What can we do with this fraction, though? It simplifies, right? Yeah. So let me do that real quick here. So negative 60 over 30. If I hit math, well, it's negative 2. All right. Yeah, so I'm going to say negative 2 over 1, though, just because for slopes you normally have two numbers. And so, again, what would be the label for this top number? Still beats per minute. And what would be the label for the bottom number? Still years. Okay? So, now that I've simplified it, I could change my sentence a little bit here and say, your heart rate changes how? By, negative 2 beats per minute. Every year, or every 1 year if you like. Yep. Okay? So that's another way to interpret it here. These two sentences mean the same thing, right? They're saying the same thing. One says negative 60 beats per minute every 30 years. The other one says negative 2 beats per minute every year. But they really mean the same thing because it's the same slope. Okay? Which one's the better one? I would say probably the second because it's simplified. Okay? So, and again, this is, of course, on average. It's data. You know, it's not going to be true necessarily for you exactly, but if you get a population of people, it'll be true for them. Okay? Questions on any of this? All right. Let's try another one here. Okay. This one, if you don't want to draw the graph, you don't have to. Okay. I'm gonna draw the graph, and then you guys can just like kind of write down the work here. Okay. So for this next one, let's see here. I'm gonna go 70, 60. Question? Yes. Go ahead. Okay, so let's say altitude, and again, you don't have to copy this graph down if you don't want to. If you just want to follow along with me, that's fine, because I know it's a lot to copy these graphs down, and maybe in the future I should have these, in the future maybe I should have these, already ready for you guys to go. I apologize about that. Okay, so let's say in this case I'm graphing my altitude, and you guys know what altitude means, right? Height above the sea level, kind of thing, your height in the air, or height on the, on the ground, but above, kind of thing. And then the temperature in degrees Fahrenheit here. Okay, I'm going to have the point 160, 330, and then 50 like this. Okay, so that's 160, 330, okay, and then 50. So again, just follow along with this one. Just follow along. If you want to copy down, you can, but you don't have to. Just follow along here, and we'll have you answer some questions. Okay? All right. Let's go to then, so again, sorry, let me pause right here. So this is maybe like what happens as you climb higher, right? We're going to see the temperature change as well. Okay? So Tyler C., what would be our setup here for the slope? Slope. What minus what over what minus what? Now, Tyler, you have 3 points here. Does it matter which points you pick?
Yeah, I can pick
whichever ones you want, as long as you pick 2. Okay, so go ahead, pick some, and let's get this slope calculated here. What minus what over what minus what?
We got 5 and 0 and 3 and 30.
Okay, so you want to use this one and this one, okay? And so what are we going to subtract on top? On the bottom, yes, is where we put the x's. But on the top,
We would put 5 and 3.
on the bottom or the top?
Top. On the bottom.
Yes, I know you meant to say that. 5 minus 3, okay, and then what goes on top?
30 and 0.
Okay, but what order? You said 5 minus 3, so now you have to say
0 and 30.
0 minus 30. Very good. Okay, 0 minus 30 is negative 30. 5 minus 3 is 2. Okay, let's go ahead and simplify this time.
You get negative 15.
Yeah, I'm going to put it negative 15 over 1 because I think it's helpful to have that, okay? The 1 on the bottom there to see the different labels and things, all right? Very good. Thank you, Tyler C. Let's go to Sean. Sean, this negative 15, according to my graph, oh, he's in the bathroom. Sean from the bathroom, answer. Okay, never mind. Simon, since my top number here I got by subtracting y's, what would be the label I can get for that negative 15? Yeah, temperature, degrees Fahrenheit. So I'm going to say degrees Fahrenheit. And then what about the 1 here? That would be 1 what?
1 mile.
So 1 mile, exactly right. Okay, so Matt T, what do you think here? What would be our sentence we get right?
Every time your altitude increases or changes
By how much?
by 1
By 1
mile,
mile, what happens to the temperature?
it will rise or change 15 or negative 15
Degrees.
Yes.
Right. Okay. Exactly. So every mile my altitude increases, okay, the temperature changes by negative 15 degrees. Fahrenheit. I guess I should put the Fahrenheit there too. Okay. Oops, sorry, I'm off the screen. There we go. Every mile my altitude. Oh, I said my altitude twice. That's weird. Okay. Every time my altitude increases, the temperature changes by negative 15 degrees. You could say for every mile I climb, the temperature drops 15 degrees Fahrenheit. That's another way to say it. Every mile I climb, okay, the temperature drops 15 degrees. So you'll notice I don't have to say negative 15 because that word drop indicates negative kind of thing. Sky, question?
So if you were to do the very top point and the very bottom point, the thing would still be the same.
Yes, exactly right. So if Tyler had chosen to use these, okay, it would be, and I'll just show you here real quick. It would be 0 minus 60 over 5 minus 1. 0 minus 60 is negative 60. 5 minus 1 is 4. Negative 60 divided by 4 is still negative 15. Okay, that's something about a line. A line slope does not change. A line slope is always the same. So no matter what 2 points you pick, you're always going to have the same slope. Okay, good question. All right. Shall we do one more here together?
You have a choice.
We have a choice? I mean, I guess, Sky, question? Bathroom? Yeah. Yeah, go ahead. Okay. One more here. Again, I'm just going to show you a graph. Okay, so you don't have to worry about doing it if you don't want to here. This one is about a dog.
I love dogs.
Me too. Unless they're mean dogs, in which case I am anxious about them. Say what? You don't have to graph if you don't want to. Just follow along with me here. Because I don't want you guys to have to worry about making these graphs. I think they take too much time up. Okay, so this is going to be the weight of a dog as its age changes here, okay, as its age is changing. So we have 1, 2, 3, 4, and 5. Okay. You don't need to graph it. Just follow along with me here. Yeah, just follow along with me. That's fine. So when the dog was born, it was 10 pounds, we'll say. And then at age 3, it was 30 pounds. And then at, 6 here. At 6, we'll say it was 50 pounds.
What's the breed?
That's
Mutt.
Well, it's very generalized.
Yes, it is. What's that?
Do you have a dog?
I used to, not anymore.
Well,
Yeah. Where I was living, I couldn't have a dog. And plus, it's a lot to take care of a dog and stuff like that. But I do like dogs. Do you have a dog, Eric?
Yeah.
Yeah. What kind of dog?
I have a miniature pincher
A
and
min pin?
yeah. And then
They're fun.
I don't know what type of dog my sister's dog
Subi?
is. Yeah, Subi.
Some sort of mutt.
it's like a
Pit bull
boxer
mix.
Okay.
She's a pain.
Okay. Yeah, exactly. Dogs can be a lot of responsibility. That's why my wife and I were hesitant to get one yet. Maybe once we have kids, we'll have a dog too. But anyway. Okay, so there's our dog's weight. Again, we have the point 0.10. We have the point 330. And we have the point 650. Okay? And again, we want to find the slope and then describe the slope's meaning. Okay? So let's go to... Oh, someone who's here. Sorry, Olivia. I know she's not feeling well today. All right, so Erica.
Oh, jeez. Hi.
To find the slope of a line, to find the slope of a line, okay, how many points do we need?
2.
Just 2. So pick 2 points, please. Any of these 2 here.
330.
330. 650. Okay, very good. And then to do the slope formula, remember it's y2 minus y1. So what do you want? Which y's? Go ahead and tell me what that'd be then. If it's y2 minus y1 on top, what number should I put in for y2? 50. Yep. And then minus, what's the other y coordinate? Yeah, perfect. And then what would the x coordinates then on the bottom? You got it. Good job. Excellent. 50 minus 30 is 20. 6 minus 3 is 3. 20 over 3, which if we try and like do that in our calculator, you get like 6.6666 repeating over 1 like that. So this is a case where it's like you can kind of choose whether you want to get like this is called the unit rate. Why do you think it's called the unit rate?
because it's the unit rate
It's over what?
of 1.
Over 1. Yeah, I mean that's true, Matt, but yeah. So this is because you're dividing by 1 here. So you could say this one or this one here. It's your choice. Okay, your choice. So we could say something like every how many years?
1,
Let's do it for this one. Every how many years?
3.
Every 3 years. What does that 20 mean? The positive 20.
It gains 20
The dog gains 20 what?
pounds.
20 pounds. LBs. Okay? What if I wanted to say every year? Every 1 year or just every year? We would say the dog gains what?
6.6.
6.6 repeating pounds. Exactly right. Okay? Every 3 years, the dog gains 20 pounds. Every year, the dog gains 6.666666, repeating pounds. Okay? You can say this in a different order, too. Some of you maybe would want to write, bless you. Some of you maybe would want to write the dog gains, you don't have to write all these down if you don't want to, okay? I'm just saying. The dog gains 6.6, repeating pounds every year. Is that okay, too?
Yes.
The dog gains 6.6 pounds every year? Yeah, that's fine, too. It means the same thing, okay? There's different ways to write this. Okay? Remember, so summary, in summary here, we're still finding slope. Right, Mark? We're still finding slope here. So it's y2 minus y1 over x2 minus x1. Okay? Slope formula doesn't change. But what does change? Now those y's and x's have a label associated with them. Look at your y-axis for your y label. Look at your x-axis for your x label. Okay? And then use those when you go to talk about it. Every, so many years or every, miles and altitude, whatever kind of thing, there was this change in my y's, kind of thing. Or my y's changed this way every time my x changed this way kind of thing. Okay? That's how you want to describe these things. All right? And so I'm going to give you guys now a chance to practice this, okay, for your assignment. So in your books, your new books, your old books, by the way, you can put those away there on the bookshelf if you want to. You don't need to carry those around anymore. Okay, and your new books on page 228, and with the remaining time in class, I would really like to get started on this. Page 228, okay, I'd like to do numbers 13, 14. Let me see, what else did I want to assign here? No, not it.
Page
Page 228. 228.
Can I see that paper?
Oof. Yeah.
Thank you.
Oh, here you need this paper. Mhm. So 14, 15. Okay, and then 21A. Okay, now 21A says find the rates of change. It's really just one, so don't worry about finding multiple there. It's really just one. So 3 problems, and then give, write a sentence to describe the slope in context. Just like we did, okay? Just like we did here. Every 3 years, the dog gains 20 pounds. Every mile I climb, the temperature drops 15 degrees Fahrenheit, okay? For each one of the, I'm only giving you 3. You have 10 minutes to do 3 problems.
Wait, for each one?
1, 2, and 3, write a sentence for each one. I know, writing in a math class, I'm asking for 3 sentences for homework tonight in addition to your slope stuff. I know it's a lot. Okay. Nope, don't do B. Just do 13, 14, 21A. Okay? That's all you have to do. You got 10 minutes. You got plenty of time to get it done. Finish it up here so you have no homework tonight. If you're stuck